Pluto has always been one of the most intriguing worlds in our solar system. Yet no matter how many times I talk about it, there always seems to be more left unsaid. Each time I share a video, the comments fill with questions like, why is Pluto so faint from Earth when the Hubble Space Telescope can capture galaxies millions of light-years away? Or, how did New Horizons take such bright photos of Pluto if it's so far from the Sun? These questions are some of my favorites, because the answers reveal just how wonderfully strange the universe really is. So if you've ever found yourself puzzled about Pluto, this is your chance to finally get some answers. Today, I'll be addressing 4 of the most common questions about Pluto. The explanations are fascinating, surprising, and even a little emotional. So let's begin with the first one: why can Hubble see distant galaxies so clearly, but struggles with Pluto? Hubble has delivered some of the most breathtaking space images ever captured, showing us galaxies lying millions of light-years away. Yet, despite that power, it can't produce a sharp image of Pluto, which is relatively close by. At first glance, this seems contradictory. How can it reveal distant galaxies in detail but only blurry views of Pluto? The explanation comes down to something called angular diameter. Let's take the Andromeda galaxy as an example. Even though it's about 2 million light-years away, it is truly enormous, roughly 220,000 light-years across. Because of its size, Andromeda still spans about 3 degrees in our night sky, which is 6 times larger than the Sun or full moon. In fact, when Hubble imaged it, the telescope couldn't even zoom out far enough to capture the whole galaxy. The image we see is a mosaic of hundreds of exposures stitched together. Other galaxies, while not as close or large as Andromeda, are still big enough to appear with noticeable size. Take the Pinwheel galaxy, 21 million light-years away. It looks almost as wide as the Moon in the sky. Because of their apparent size, galaxies like these are easier for Hubble to image. Pluto, on the other hand, is tiny from our perspective. To measure sky sizes, astronomers use degrees, arc-minutes, and arc-seconds. The Moon is about 30 arc-minutes across, while Pluto is just 0.11 arc-seconds wide at its closest approach. That's unbelievably small, which makes it nearly impossible for Hubble to capture in detail. This is exactly why the New Horizons mission in 2015 was so groundbreaking. We had no idea what to expect until it arrived and sent back its close-up views. Think of it like this: imagine a photo with a blurry flower in the foreground and sharp buildings far in the background. The flower represents Pluto, and the buildings represent galaxies. Sometimes distance and size don't work the way we intuitively expect. Here's another curious fact: Pluto and its largest moon, Charon, don't orbit around Pluto itself. Instead, they both orbit around a point in space between them. To some, that might sound like evidence of a hidden, invisible object, maybe even a tiny black hole. But there's no mystery here. The explanation is gravity's center of balance, called the barycenter. Everything in space orbits around a barycenter, not necessarily the larger body. For most planets, the barycenter lies inside the planet because it's so much more massive than its moons. For example, Earth and the Moon share a barycenter, but it's located inside Earth. With Pluto and Charon, their masses are much closer in size. This pushes their barycenter outside Pluto's surface. As a result, both bodies swing around this invisible point in space, almost like a cosmic dance. The same thing happens on a larger scale between Jupiter and the Sun. Their barycenter is also outside the Sun's center. Another frequent question is, if Pluto is so far from the Sun, why do New Horizons photos look so well lit? Shouldn't Pluto be nearly pitch black? If you looked at Pluto with your own eyes, it would indeed appear dim compared to Earth. But it wouldn't be as dark as you might imagine. NASA even coined the term Pluto time to describe it. Twice a day here on Earth, at dawn and dusk, the sky is illuminated with the same brightness as Pluto's midday. On average, Pluto receives just 1/1/600th the sunlight that Earth does. Direct sunlight here measures about 100,000 lumens per square meter. On Pluto, that drops to around 60 lumens, the brightness of a hallway light. While dim, it's still more than enough for a spacecraft camera to capture with longer exposure times. Add in some image processing, and Pluto suddenly looks much brighter in those iconic photos. And now to the question that stirs the most debate: why isn't Pluto considered a planet anymore? Believe it or not, we used to list more than 100 planets in our solar system. In the early 1800s, objects like Ceres, Vesta, and Juno were discovered and labeled as planets before later being reclassified as asteroids. Pluto faced a similar fate. When it was discovered in 1930, Pluto was hailed as the ninth planet. But over time, astronomers noticed inconsistencies. Its orbit is tilted and highly elongated compared to the others. Later, scientists realized Pluto was far smaller than expected, only 1/6 the mass of our Moon. Things became even trickier in the 1990s when astronomers discovered other Pluto-like objects in a region beyond Neptune now called the Kuiper Belt. Worlds like Eris, Haumea, and Makemake showed Pluto wasn't alone. By 2006, the International Astronomical Union defined a planet as a body that orbits the Sun, is massive enough to be spherical, and has cleared its orbit of other objects. Pluto meets the first two conditions, but not the third. Because it shares its region with countless Kuiper Belt objects, it was reclassified as a dwarf planet. Rather than an insult, this opened the door to a whole new category of celestial objects worth studying. As a bonus, Ceres was promoted from asteroid to dwarf planet too. So there you have it, for mysteries about Pluto, answered. Of course, every time we solve one puzzle, more questions appear. That's the beauty of astronomy: the deeper we look, the more there is to discover. Pluto may no longer hold the title of planet, but it remains one of the most fascinating worlds in our solar system. If this video sparked new questions in your mind about Pluto or the wider cosmos, drop them in the comments. Who knows, your curiosity might shape the next topic. For now, though, I hope you've learned a little more about Pluto's secrets.